Welcome once again to another class in C++. Today we're going to cover a few items out of the C and C++ standard library. It's not just C++. Most of what C++'s library is from C and has been modified in some cases, not always. Okay, the C++ standard library comes with a variety of useful functions, and you're not going to get too far without knowing how to use many of them. Well, for example, we can get the current time. You almost always need the current time. You can format the time in different types of methods. There's some mathematics-oriented functions, trigonometry, sine, cosine, tangent, those kinds of fun things. If you don't do that type of work, don't worry about it. The library is there. You don't need to use it. And there's random numbers, which is very important, especially if C++ is very popular with games. And of course, random numbers are very important with games. And you throw the spear, there's an 80% chance it'll actually hit. We have to calculate a number that's 80% chance. Functions for character testing, conversion, and manipulating C character array strings. Now, the C++ string object has its own methods, but sometimes you still need to deal with the C character string array, and there are functions to manipulate them, and we need to know how to work them. Okay, we're going to get some system time. What time is it? You need to include the C time library, include file. We have a system-defined function, time, which just gives you the time. It gives you a long value right now. This is going to change at some point in time. And it's typecast into time t. So basically, you will be using this type. So if when they decide to change it to something else, your code won't break because you'll have time t. So it'll set a time t variable, and it also returns a time t return. You can ignore the return because you have to use the variable. And what it returns right now is the number of seconds since January 1st, 1970. And there's various theories as to why 1970 was chosen as opposed to 1980 or 1943. We're not going to cover any of those. Here's an example. So here we are including the C time include. We're declaring a variable, time t, we're going to call it right now. And then we're going to get the time. Now we're doing this both with the return and setting the variable, but you don't really need to do that because it's kind of redundant. So all you really need is this portion right here, is to set the time variable. And then we're going to print out the milliseconds since 1970, and we're going to print out right now, and you'll get this nice large number for the number of seconds. Now, I'm sure you guys remember the Y2K bug when it was 1998. It was going to be 1999 coming up, and in the year 2000, everybody's worried, oh no, all the computers are going to think it's 1900, and the airplanes are going to fall out of the sky, and the elevators will go sideways. None of that happened, of course. But there's another similar bug on the horizon. The seconds since 1970 is stored in a signed 32-bit int, which is sometimes called a long. It depends on the architecture. Now, that is 2,147,483,648 seconds, which is this many minutes, this many hours, this many days, 68 years. Now, 68 years plus 1970 means time will run out in the year 2038. Now, this is known as the Y2038 problem, or the Unix Millennium bug. Now, there's a number of solutions being knocked about because right now there's no real urgency to worry about that. The only programs that will start crashing are programs that are dealing in decades into the future. But at some point, they're going to have to come up with a solution. The most likely solution is going to be, instead of a 32-bit integer, it will be a 64-bit integer is returned. The number of seconds is 1970. They might come up with a structure. We don't know what they're going to do. So there's no universal solution that everyone likes. So just stay aware. Be warned that you are not always going to be able to just grab the number and pretend it's an int, because it might not be an int. Now we've got the time. We want to see it. Humans like to see the time. We don't want to see this big long number. We don't know what it means. So we have a cTime function, which retrieves a pointer to a C string array, which contains the human-readable time. So as an example, we have time. We have t instead of right now, and we're getting that time. So now that function has returned the current time. And we have a character string. It's getting, and you notice we're still passing in an address to that pointer. Just about all of the time functions deal with a pointer to the time object, because it may be an int at some point in time in the future. It may turn into a struct. We don't know, so always pass in the pointer. And then we print it out, and I'm not going to tell you what it will look like. That's part of your homework assignment. Write a little program, do this, run it, see what it looks like. Now, the string that's in this cTime function is in static memory. It doesn't allocate new memory or anything. There's two things to worry about that. One, you don't have to free the memory that's been allocated. The other one is, every time you call it, that same static memory will be overwritten. So if you need to get current time and then save it, and then some seconds or minutes or weeks or days later, you need to call it again, you'll need to call it and save it in a separate location. So you'll need like a char C1 to get the time, and then minutes later you can have char C2 and get the time again. You'll have to use a string copy. This pointer part won't work, because they will just point to the same memory. So you will actually have to have a char C1 with some number of, but you will have to actually have some memory available for that. We'll cover later how to copy the memory from the pointer into an array of characters.